question number 1, if you turn to the very last page, question number 1, asks you to give the reactions that occurred at various steps in the lab. So you cannot probably do those yet. So I figured I'd give them to you. So let's talk about, if you don't have the lab, write it down on a sheet of paper, and you could always transfer it once you find the lab. In part A, which was the front lab bench, basically what we were doing was taking calcium, which was a solid metal, and reacting it with water. We added the calcium to the water. And I'm going to write water a weird way just for a moment so that you can understand how this works. Part A involved single replacement reactions. And we've already dealt in other labs with what a single replacement reaction is. Anybody remember my nickname? It's way back in the first lab. This type of reaction is known as the other woman or other man. I'm not sexist, I don't really care. Okay? So what happens is you have a compound, right? Hydrogen here is part of a compound. It's bonded to oxygen. There's 2 different elements there, right? They're chemically combined. We wrote a formula for them. Well, what happens is calcium comes along and it's more reactive than hydrogen. So calcium boots hydrogen out of this compound. I think I did something with like Barbie and Skipper or something like that. No? Not? Okay. All right. We're going to review this again this unit, so that's why I'm bringing this up to you. You have to have these equations written down, so make sure you write them down, okay? On whatever you need to write them down on. So calcium kicks hydrogen out, and you made hydrogen gas, which you collected in the top test tube. And the calcium then got together with what's left, which is what the OH. And don't worry right now about why I'm putting a 2 there. That, again, we're going to get to in this unit. So we made the hydrogen gas, and then this thing is our base. This is the white substance that was in the bottom test tube that when you added the phenolphthalein turned pink. Okay? So that is one of the things that happened at that station. And I'm all about balancing because right now it looks like we have 2 H's over here, but 4 H's over there. So we violated the law of conservation of mass. Can't do that. So one of the things we'll also be learning how to do in this unit is balance equations. But for now, we'll just stick a 2 there to make it balanced. And I'll show you how to do that later on in this unit. At this station, we also reacted the magnesium with the water. And it reacted the same way, just a lot slower. And you didn't generate enough hydrogen gas to test positive. But you still did make hydrogen gas. And you know you made the base because it should have turned the bottom test tube pink. Okay? So that was the reactions at station A. You should write those down so that you have them for question number 1. There are other parts to the lab. We have part B, but in part B we weren't reacting anything. In part B, all that we did was test the pH, right? We didn't add anything, so there's no reactions for part B. We do have, excuse me, we do have reactions for part C. But I do want to mention that part C was physical. All we were doing was dissolving. But we can write reactions for dissolving. They're called dissolution reactions. If you remember in part C, we weighed out 1 gram of 3 different white powders. The first white powder was magnesium sulfate. And we added it to water. Now, in this circumstance, the water did not react with the magnesium sulfate. It only broke it apart, which is why I write it above the arrow instead of adding it to this, right? Because they didn't react together. It's not a single replacement reaction. You didn't make anything new. When you dissolve, what you do is you break that compound apart into the individual charged particles that compose it. And magnesium sulfate is made of magnesium ions and sulfate ions. So you simply break it apart. You don't, it looks like you change it, but really if you got rid of the water, it would go right back to the white powder. You could just evaporate the water and then you have magnesium sulfate left. So you didn't make anything new. You just really changed phases. You went from solid to aqueous. You really just changed the phase. That's all you did. And phase changes are physical. And you did that for each of your powders. You also did that for your calcium sulfate. right? And you did it for your barium sulfate. They're in the same group, so they all have the same charges. Yep, it just dissolves. It was a dissolution reaction. That's all that happens when you dissolve is like you rip the compound apart into the ions that make it up. So like when you dissolve salt, you don't have to write this one because we didn't do it. But when you dissolve salt in water, you rip it down into the sodium ions and the chloride ions that compose it. And then you can't see it anymore because those particles are too small for your individual eye to view. Okay? You could view, it's still there. The water tastes salty, right? And the water's wet. If you evaporate the water, then the salt reforms back together as a solid. So don't write this one. I was just showing you something else, okay? Questions about part, what was that, C? Part C? All right, and then finally we have part D. In part D, we were reacting, and it's not a single replacement reaction, it's a double replacement reaction. Double replacement reaction. So it's not the other woman, but I do have an analogy for you. It's like wife swapping or swingers. So there's no one by themselves this time. Everybody's a couple. In part D, we took magnesium chloride, and it was a solution, but it's a compound. Magnesium's married to chlorine. In fact, it's married to 2 chlorines. Okay, that's why it's MgCl2. It's 1 magnesium, 2 chlorines. They're married. And we reacted it with another married compound, sodium carbonate. Sodium carbonate. Okay, and what they did was swap partners. So the Na and the Mg, the metals, switched places. That's what happened. The positive ions switched places. They swapped partners, like wife swap, right? On TV, there's that wife swap show, yeah. Right? Okay. So they swapped wives. So now the Na was with the Cl, and the Mg was with the CO3. And again, I like to balance my equation, so we'll put 2 there to balance your equation. The NaCl you actually could not see. Salt dissolves in water, so this was aqueous. But if you remember, and I don't know if you do, if you look at your observations, you may note that your observations say for this part that there was like a chunky substance formed on top or a solid that formed on top. To me, it looked like somebody kind of hocked a loogie in the solution in the test tube. That's what it sort of looks like. It looked like slime. Okay, that was that. That was a magnesium carbonate. That was the solid, the new substance that you made. So this is called a double replacement reaction. Okay? And it happened with all 3 of them. It happened with the calcium chloride. Except obviously in this, if it was calcium chloride, you didn't make magnesium carbonate. You made calcium carbonate and sodium chloride, right? Swap partners. The Na goes with the Cl, right? The Na takes the Ca's place. So you have Na with the Cl, and you have the Ca with the CO3. Calcium carbonate is what eggshells are made out of, what seashells are made out of, and what chalk is made out of. Remember back in the day when there used to be chalkboards? Are you guys even old enough to remember what a chalkboard is? Yeah. Okay.
And
all right, I didn't know. What?
And overheads.
And oh, I still have my overhead. I can't part with my overhead. In case of emergency, I have my overhead. Well, because sometimes these bulbs go, and then what? We don't have, I mean, that's all the board space we have. It's not a lot, right? So I just bust out the overhead. And then also the barium chloride. And you make NaCl and barium carbonate. Okay? So those were the reactions that you need. I know that you would not be able to come up with those yourself, nor would I expect you to yet come up with those yourself. What you will need to do then to get credit for this lab is finish I think there's what, 3 more questions, 4 more questions? Okay? All the answers to those questions are either in your periodic table or they're in the background information before the procedure, okay? And make sure that your data table is complete, not just with observations, but also with conclusions. Remember, you have one conclusion for part A, one conclusion for part B, one conclusion for part C, and one conclusion for part D. And in your conclusion, in your data table I'm talking about, you should be answering the questions that I posed before each part in the lab. Like before group A, part A, if you look right before the procedure, it's in bold. I say, what happens to the reactivity as you go down group 2, and what do they make when you mix them with water? So in your conclusion, you'll write, as you go down the reactivity, what happens as you go down group 2? Do they become more reactive or less reactive? They become more, calcium was way more reactive than the magnesium, right? So as you go down, they become more reactive, and what do they make when you put them in water? What did they make in part A when you put them in water? Helium? Hydrogen gas is one thing, you got that. Oh, I guess it's here. You make hydrogen gas and a base. So in your data table for part A, you're going to write reactivity increases down the group, and when you react them with water, you make hydrogen gas and a base. Done. Okay? You have to answer those questions though in that data table. Any questions for me on that lab? It's due tomorrow, first due date, by Friday, next due date. Yes?
I provided
Do you have all the reactions and everything?
I provided, but I think I need it.
Okay, it's probably at home. I probably put it in my folder to be graded at home, and I'll return it to you, yes?
Do you have a problem with me, like, instead of writing it right here, I can write this on a separate sheet?
Sure. I do not have a problem, I mean.
It's like a...
That's fine. Any other questions? Going once on the lab, twice on the lab? Okay, sold.